All right, these next couple of videos are going to basically just give you some more details about what that previous video introducing buffers was about. So a lot of this stuff is going to be a review, but again, it's really, really important to understanding buffers and how they affect titrations, which again, we'll talk about also some more here in the next little bit. So when we talk about buffer capacity, remember that we said the purpose of the buffer is to keep the pH from moving in a drastic direction. And the reason that that does that is because a buffer solution contains some weak acid and its conjugate base, or a weak base and some of its conjugate acid. And so when you add some acid or some base to it, it reacts with one of those two components and again keeps the pH roughly the same. Okay, but as you continue to add more acid or base to the buffer solution, eventually that acid or base, the acid or the conjugate base that was there is going to run out. Okay, and so you will reach the capacity of that buffer eventually, and that it won't be able to hold that pH level for an unlimited amount of time. So the capacity of the buffer is defined as its ability to continually react with any extra acid or base that's added to it. And again, the pH isn't going to change very much. And so the more of that acid and conjugate base you have in there, or the higher the concentration of your buffer solution, the higher its capacity is going to be. Okay, if you have a 0.1 molar solution of a weak acid, and you also have 0.1 molar of its conjugate base, and they form a perfect buffer solution, okay, versus a 0.5 molar solution of each of those, which one's going to be able to resist that change longer? Of course, the 0.5 molar solution, because there's more acid particles and more conjugate base particles in that solution. So the higher the concentration, the greater the buffer capacity, so that you have more particles for the extra added or base to react with. Okay, so buffer capacity. Okay, and again, we talked about this in the previous video. Why doesn't the pH change when you add some acid or some base to a buffer solution? So remember, our buffer solution, yes, I think in the previous video I did it with a weak acid and then its conjugate base. So today let's do it with a weak base, just so we can kind of see. So again, here's our buffer solution. So we're going to I'll do 5 of each, unless I draw them all too big, and then I'll run out of room. Okay, NH3. So when NH3 is a weak base, when you put it into water, it will create an equilibrium system, NH4 plus and OH minus. But again, that's an equilibrium system. You get very little of this and mostly this. That's not a buffer solution. Okay? A buffer solution's got to have a good concentration of the base and its conjugate acid. So if we react this with like HCl, then you're going to get NH4 plus and Cl minus. So again, remember how you create a buffer solution. If you have 50 milliliters of 0.5 molar NH3, you could you could do it like this. You could do 50 milliliters of 0.25 molar. That would be fine. Or you could go 25 milliliters of the 0.5, because all of that is going to react, which means half of this is going to be gone. And you're going to get, again, about half as much of NH4 plus. So now we're going to have equal concentrations of NH3 and NH4 plus. Okay, so there's our buffer solution right there. Okay, so if I start to add some acid to that, okay, so I'm going to add some strong acid to that. What's the reaction going to do? Well, the H plus that I add is going to react with the NH3 to form more NH4 plus. So all of this NH3 is slowly going to start to turn into NH4 plus. And what does the pH do? Not much. Okay. And if I add some base, some OH minus to the buffer solution, what's it going to react with? It's going to react with the NH4 plus. Again, this is the conjugate acid. Remember, the base always reacts with the acid component, and if you add acid, it always reacts with the base component. So if I add some OH, not OH plus, OH minus, it's going to react with the acid to form NH3 and H2O. Okay? So notice that whether you add some acid or some base to a buffer solution, the whole point is the pH isn't going to change very much because the acid that you add reacts with the base that you add will react with the acid until, again, you reach that buffer capacity. Okay, so let's go back through this top part up here. Okay, so if additional base is added to a weak acid buffer solution, the hydroxide ion of that strong base that you've added will react with the acid component of the buffer, producing more of the conjugate base. So again, let's switch back to an acid one. So if you have a buffer with a bunch of HA and a bunch of A minus in it, again, an even amount, then again, if you add some OH minus, that's the base, what does it have to react with? It has to react with the acid, with the HA, and what's it going to form? H2O and A minus. Okay, so it's going to react with the acid component producing water and more of the conjugate base, more of that A minus. So remember, here's our buffer solution right here with HA and A minus. Basically, you add some base, it's going to make that acid turn into conjugate base. Okay, again, the pH of the buffer doesn't change very much, if at all, because, again, the concentration of hydrogen or hydroxide hasn't changed because, again, the base that you added immediately gets used up to produce more of the conjugate base. Okay, so in this buffer solution here, again, you've got a large concentration of this, you've got a large concentration of this, and you've got a really small amount of this. Okay, again, how did that buffer solution form? You should know that. There's two ways that buffer solutions form. You either reacted enough of this to turn into this, or you added like some NaA or some Ka, something that's soluble that has the A minus ion in it. So then when you add the base, what does it react with? With the acid to form more of the conjugate base. And when you add an acid to a buffer solution, okay, when you add an acid to the buffer solution, a strong acid is going to react with the conjugate base portion to reform more of the acid. Okay, so we saw, here's the example when you have a base buffer solution, and then you have this example here, and this example here when you add an acid or a base to an acidic buffer solution. Okay, and then you kind of see that here in the chart. Here you've got a buffer solution. You've got an equal number of moles of acid and base. If you add some hydroxide, the hydroxide is the base. It's going to react with the acid component, this one here. Okay, and it's going to react with that to create some water, and then more. Notice that the amount of the conjugate base goes up, the amount of the acid goes down. But again, it's still a buffer solution. Okay, you've still got some acid, some acid and its conjugate base. If you add some acid, what does the acid react with? It's going to react with the conjugate base. Okay, here's the acid reacting with the conjugate base. Okay, it's showing it as going backwards, but it's really just a forward reaction. It's just because it's going left, it's causing that, making it look like that. Okay, it's going to react with the conjugate base to reform more of the acid particles. Okay, so really important there is knowing what happens, what are the reactions that happen when you add some acid or some base to a buffer solution, and why does that pH not change? And then understanding the idea of buffer capacity, and the higher the concentration of those acids and conjugate bases, or bases and conjugate acids, that's what's going to determine how much acid or base you can add without the pH changing dramatically.